Welcome to my assignment 6 for the transport, pavement and geometric design 3. My name is Mapola Dorothy Make, and I'm going to be taking you through the project that we have designed for the road. And my email address is 47092521@mylife.unisa.ac.za. So we are actually upgrading a road from gravel to 2-lane surface road. The road is D885, and the project background there's a new shopping center, and we are designing a new road to serve as a collector road linking the surrounding villages to the new shopping complex. The road is in Limpopo province. It's about 70 kilometers southwest of Mokopane, and it's 3.4 kilometers. This project contains the civil tree design steps that we have used, and of course the drawings that which will be showing the layout. It will be showing the layout, the profile, the cross-section, the quantities of the road, and they are from the civil tree design. The manual calculations also, the Excel spreadsheet for the manual calculation of the curves, and we also do the pavement design, and we have also done the screenshots that shows the procedure as we are doing our design and the Excel. So these are the steps that which we did for the civil tree designs. The first thing that which we did was we adjusted the drawing settings to the zone in Limpopo, and we imputed the survey data for the road, and we created the surface with the survey data, and from there we were able to create alignment profile and pavement assemble. And with the three alignment profile and pavement assemble, we created a corridor, and then we made that corridor a surface so that we can be able to create sample lines and compute materials for the quantities. We also created frames for the alignments, and we were able to also create sheets for layout plans and profiles. And we created multi-sections for cross-section, and then we printed or plotted the whole thing to PDF, and we were also able to print out the quantities of the report. Now in our horizontal alignment, we had a curve, and according to the standards, since our design speed is 100 km per hour, our minimum radius is supposed to be 350 meter, according to the table 3.21 of TR817. As indicated there, you can see design speed of 350 meters of the minimum radius, and the curve here shows that the radius is 695, which means our curve is fine. And here we did the manual calculation to indicate and confirm if the curve or the design is according to our South African standards, and that is we took R as given, deflection as given, we took the channage at the beginning of the curve as given, and we were able to calculate the length of the curve and the channage at EC. And the length of the curve calculated using a formula, the answer that we get is 408, and from the curve we can see that the length of the curve is 488. The end of the curve was found to be 47 kilometers, 8.75 meter. It's also correct. The end of our curve is 47.8. It's 47 kilometers, 8.75 meters. And we also imputed all the values on our spreadsheet on Excel, and we put the values and have put all the formulas to do the calculations. As you can see, they are indicated there. Everything is the same. Pavement structure, our CBR, we have two CBRs. As you can see, the points and the changes there. So our CBR, we have two areas for SG2 and SG1, which is SG1 is the CBR above 15, SG2 is a CBR of between 7 and 15. As you can see, it's indicated there. So these are going to be our sub base. The bottom layer we rip and recompact 150 G9 for a design SBR of 7 to 15, and the top layer there will be 150 millimeter G5. But of the one that is CBR is greater than 15, we only rip and recompact to 150 millimeter of G4. Our cross section, the lane width is 3.6, the shoulder width is 1.5, and our travel way is 7.2, roadway is 10.2. So these are our design data for the alternative basis. ADE is 375 EDT per lane per day for from the design date, the basis. And then for 20 years it's 5.5, which gives us the pavement class of ES10, and our traffic growth is 6%, road category is B, and the climate is moderate. With that information, these are the alternative basis that we find. Granular basis, we find that we can use a surface layer 40A, base 150 millimeter G2, sub base 200 millimeter C4, subgrade upper layer 150 millimeter G5, subgrade R plus R 150 millimeter G9, or we can use a layer of 3A, base 150 millimeter G4, sub base 200 millimeter G5, subgrade upper layer 150 millimeter G7, or subgrade R rip and recompact 150 millimeter G9. We also did for odd mix alphas. We can see the surface, we can use 30 millimeter, base 80 millimeter BC, subgrade we can use 300 millimeter C3, and the subgrades there. For cement bases also it's 150. For the surface layer it's 30 massite, base is 150 millimeter C3, sub base is 300 millimeter C4. For waterborne merchant bases, we find that we can use a surface layer of 40A phosphite, and we can use a base of 125 millimeter WM1, and then a sub base of 125 millimeter C4, and another sub base of 125 millimeter of C4, and the subgrades. But the one with this SBR of greater than 15, the subgrade will be different. It's the very same thing, but the subgrade will be different. Our subgrade is we only rip and recompact G7. So as you can see here, what we selected is we have selected the granule basis, and we only selected to use a base, the base of 150 millimeter G2 and sub base of 200 millimeter G5, because this pavement structure is selected because the material are the most economical and will be imported from the nearest borough pit. So this is the final selected pavement structure according to the different SBRs. Surface layer 30 asphalt, base 150 mm G2, sub base 200 mm G5, and then the subgrade of 150 G7 and rip and recompact 150 G9 for CBR of 7 to 15, or if the CBR is greater than 15, we're going to put a subgrade of rip and recompact 150 mm G5. Drawings are attached in the report. Thank you. The end.